Hello guys, welcome to the another video in Rust programming tutorial. This is the fourth video in this tutorial. In the last video we have started like Rust data types and we have already discussed about the integer data types like signed and unsigned integer data types. Now Rust has both single and double precision floats and it supports both F32 and 64-bit data types of float. So here in this example I have taken two floats. One is with 32-bit, another one is with 64-bit. Here we can see that the first one is 3.23456, the second one F64, the variable name is F2, and this one is like 8.87654. Okay, so and also I have some couple of println statements. Here we can see that in this case we are directly printing both F1 and F2 value. In the second case we are asking up to 2 decimal points, like this is the format specifier. The curly braces indicates the format specifier. Inside that we have given like dot 2. That means after decimal point, after dot, we only want two numbers up to 2. Okay, so in the third case we are asking up to 7 decimal points. After dot we have only 5 numbers, but we are expecting 7 numbers. Let's see what happens. And I wanted to tell you one more thing, that the last video code like integer data types is also part of this, because I kept it in the same file so that I can upload in the Git, so that all the data types code will be in one single file. Let's execute this. As you know that this project is created with a cargo. So cargo is Rust inbuilt tool set. With this we can create the projects and we can compile it and run it both debug and release mode. For now we will give the command like cargo run. See, since we have this integer data types code also in this, and we have not called in the main function, so that it is giving a warning that it is a dead code. This is like a compiler statement. If you add this on the top of the file, like instead of warning allow, it will allow us to do the things like without the warning. Those things I will discuss in the future videos. For now let's stick to this float data types. So now the print statements came. So the first case the floats got printed. In the second case we see that up to 2 decimal points precision it got printed. And in the second case, since the 6 is more than 5, so the one value got added, like that's why it's 8.88. In the third case we are asking up to 7 decimal points. We can see that since we have only 5 numbers after the dot, the remaining 2 are filled with 0. Okay, so we have seen the float data types. In the Rust we have other data types also, like boolean and characters. We know that strings is nothing but collection of or combination of characters. So now we will see the other two data types like boolean and also this char data types. Let's define one more function. Okay, let's take let b1 equal to true and let b2 equal to false. Okay, so I have taken two boolean variables. If you notice this, I haven't mentioned its data types, because Rust has capability of inferring the data types. So by default, even though if you don't mention that particular keyword, either it is a boolean or i32, i16, f32, it can infer it data types. If you give I equal to -10, it can say that it is like minus i32, because like it's a signed integer. If you mention something like this b1 equal to true, so it can infer that it is a boolean data type. Okay, but let's take for example, you just wanted to declare here like b1 is bool, and you have not initialized there itself, and you are initializing down below, then you have to mention it is a bool, otherwise it cannot understand the b1 data type. So but if you are doing in place initialization, no need to mention explicitly any data type name. And now let's have one println. We will say like is good. Let's call this and now comment this. We can, yeah, we can see that is good true, and did he graduated false. So the other data type I have told is like a char. Now let's take ch equal to one single character like c, we can take it, and it will occupy 1 byte of data. So let's take other one is like let emoji. Let's take one emoji. So this class emoji will take up to 4 bytes. Okay, so here also I am directly mentioning like ch equal to this one, emoji equal to this one. I am not explicitly having that keyword like this char. Okay, so for characters we should mention like this, but as I told, the Rust programming developers will not explicitly mention this particular data type, so that we are also following the same. Okay, now let's have like println. So now if we execute and see, yeah, the carry C and the favorite emojis with the classes. Okay, so as I told, this is like some kind of tip. I told that if you mention this on the top of the file or anywhere, if you mention it, it will not give you this warning. What we can do, let's go to the top of the file and put this here, and we should also have something this exclamation mark, so that it can understand that it's a compiler statement. Instead of warning, let's put allow. Okay, and see now without any warnings we are able to do this, but this is not a good way to do this because our compilers always try to optimize the things. If you had these kind of statements, our code length will increase without doing any functionality. So there is another way. Let's say for example you are not using any one variable. How we can avoid the warning like it's unused variable, and also typecasting of the variables. And also I think in the last video itself, all the variables whatever we have defined here are immutable. You cannot change its value directly. How to make them mutable, those things I will be discussing in the next video. Thank you for watching. Please see the content in our channel. If it is useful for you or your friends or anyone, just please share and also subscribe and comment out. Thank you for watching. We'll push this code in the Git. From there you can take it. I will keep the Git link in the description.